Okay, if you
Okay,
don't know Nico, Nico will introduce himself then to talk about the Pipettin robot. Go ahead.
okay. So I'm Nicolás Méndez. I am a PhD student at the University of Buenos Aires in Argentina. And well, this day's Open Auto Club will be about a pipetting robot and a lab automation platform we are developing. So thanks, Tim, for setting the whole Open Auto Club up and for inviting me to give this talk. I'm very excited about this. I'm very thankful as well for all of your time. And please interrupt me at any time if you have questions. Unmute yourself, and let's make a little mess if you want. So the contents of the talk would be the open hardware liquid handler, about our group in Buenos Aires, and about the anatomy of a micropipette. So I hope we spark some discussions from this and also try to get us working together. The scope of these projects is really enormous. So there's room, I think there's room for everyone to do something different. And if we get it to converge, then we will build something amazing. So part one. So why do a pipetting robot at all, right? So in my particular context, commercial options are costly and also proprietary, which we can discuss, but in my opinion, has imposes some limitations to what you can do with it. Another thing is that existing open projects are not commercial, so I could not purchase one. And also, at the time when I started doing this, I had time to spare, quote unquote. So in short, the technology is not really accessible to most of the world. So I think that while most of us here, or most of you here, may be used to having robots around, or perhaps not, this is a very strange thing to see in many places, if not most places. So this is also one reason. So being one of them, I'd like to make a robot that everyone can have. So what are some previous works? The Open Trans 1, that's perhaps what was so interesting to so many people, because it could be replicated. So all STL models were available, and it was open hardware in general, and also open source software. It had I'm not too familiar with the story, but as far as I know, it had this great start, but then kind of lost its way in the openness sense. And there are at least 24 other open source robots that have been published. So I keep a little list on issue number 63. You can visit that. But however, none were well documented nor commercially available, except for Jubilee, which it became the sole exception when it became Science Jubilee. I think I learned about it when it still was only a tool changer 3D printer with some interesting things on top of it. So my motives for this, or our motives really, is to lower the entry barrier to lab automation for everyone, and to develop and also try to commercialize a 100% open and hackable lab robot, and also to have fun and get way too carried away. So I'm a biologist, so I don't know how I really ended up here. So let's see some of the outputs of the project so far. The main output, of course, is the robot itself. It is a simple Cartesian robot. And what we chose to do, why we chose to do it this way instead of other kinds of kinematics like CoreXY or a slinger bed or other kinds of motion systems that you find on 3D printers, is that we needed a more traditional system for load-bearing applications, which means that essential means to place and remove tips from a pipette. And perhaps other things too, which we have not yet thought about. Also, this is very easy to scale. In size, you just change the length of the propels and the belts, and you're done. If you need something bigger or smaller. And these slides will be interleaved with some notes on interoperability, because this has been one of the one of the key design ideas or goals is that to have interoperability with as many things as possible. The framework we chose for this was to drive the machine is Clipper, which in my opinion is great in the sense that it is able to run on a really wide variety of microcontrollers. So the Clipper is running here on the bed. And in the previous robot, it was synchronizing to Arduino Uno CNC shields, which are simply everywhere. And you can use a really expensive board or 2 Chinese Arduino clones, and it will work anyways. Also, Clipper does not require the Raspberry Pi that I see around, which at the time was really hard to get due to supply chain issues, if you remember, during the pandemic. So you can use a Linux computer, and that will work just fine. There are some caveats, but I think that this idea about being able to run in many controller units should be, I think it's a good idea that should be kept even if we move away from Clipper. The second output, I think one of the most important ones is a pipette. So the first pipette we had is just an adapter for Gilson single channel pipettes. It works really well. And one of the ideas was to keep it interoperable with other existing projects, and that's the reason why there's a Jubilee here. Thankfully, we got an invite to the post workshop organized by Nadia Pic and Lilo, and I got the opportunity to try to load this onto the robot, and with lots of help, we actually got it to work, and it was great because all we had to change is one little part. Even though a tool changer is slightly different, it worked with a small change, and that was really great. Here is it on our robot, and here is it on the Jubilee. And then there's the new pipette, which is meant to go along with this one. So if you have a pipette already laying around, then you can use that one. And if you have access to a CNC machine, or you want us to send us this part, then you can probably get all of the others and 3D print the others, which are generic parts. This is a multi-pipette multi-tip tip holder, so you can fit any of the 3 kinds of tips in there. And after a few, manual tests in the lab, spinning it by hand and weighing it, it actually works quite well with all 3 tips, although this has been just this week. So I'll keep you posted on that. Here is the workshop which we're just talking about. So I actually, the first iteration of the robot's tool changer was like this very simple pair of rods inserting into linear bearings and holding with magnets. And there's the pipette. And it evolved like through 3 intermediate iterations onto what we have right now, which of course, as I said, is compatible with Jubilee, with the idea that the work that we do over here and what everyone else does with Jubilee is interoperable and can be reused everywhere. So I think that there should be some kind of record. So between Seattle and Buenos Aires, there are 11,000 kilometers. And this wasn't tested at all before I went there, and without reprinting any parts and only minor surgery, the thing worked. So I think this is really cool stuff. Another output of the project is, well, all of its software. The fanciest of it is the graphical user interface, which is a web user interface. You open this on your browser, whether if it lives on the Raspberry Pi or your own computer, and you can add these labware, whichever kind of labware you have. So if you have like this random shape stuff, you can use that, no problem. So they don't have to adhere to the SBS standard. It can be just anything. The way to align them is with these curves or anchors, which just snap into place. You have to calibrate those, of course, and other stuff. But after that is done just one time, you can use it. Then, well, it has lots of things. You can create, validate, and run protocols from this place with no code at all. The data structure is quite flexible for liquid handling, but it was meant to keep things, loosely defined to add other kinds of steps to the protocol. And there's also a templating system for auto-generated protocols and workspaces. So the idea is that you can, I will not show it right now, but you can edit a template and tell him, I want this combination of primers and templates and concentrations of things, and it will populate everything with tubes and protocol steps, and you just hit play and it will do it. So it will be very easy to use. Here's some
Hey,
more.
Nico?
Yeah.
Just on the last slide, maybe you said this and I missed it. How do you set the anchors? Like, how are they fastened, or how do they get positioned on the deck?
Yeah, let me show you. So here in Jubilee, you have the deck, the 6-slot deck that is very similar to OpenTrons, if not with the same dimensions.
Mhm.
And here you have a grid of holes that are separated by 5 centimeters. And it is not shown very well here, sorry about that. But here you have the curves themselves. So the little L pieces and straight pieces that just fit there. And so you choose your layout and you calibrate it. And that's it. You can, of course, change it, but you can also remove the entire base plate, which sits on the rod with a kinematic coupling, which is the same idea, actually borrowed from Jubilee, only that it's static. The idea is that you can remove it and then play around with it and then put it back or put it on another robot, and it will sit exactly in the same place as it was before, but the z-axis is free to move elsewhere. Yeah. So there's a bit of manual work there that you have to, through which you have to match the virtual workspace to the physical workspace. But once you do that, it's done. And also, I don't think you will be able to see it here, but I have been playing with defining the OT2 deck. I don't have an OT2, so I have nothing to test it with, but it still was an interesting experiment. So here's, for example, a form to define the parameters of the labware. There are different kinds of labware, and they are displayed there. And the joystick is the mainsail UI, a web interface also for Clipper. A really nice, that is like a sister, would be the twin of the Duet control interface. They serve the same purpose. And then the interrupt slide here is that actually for a couple of years now, very slowly, I've been working on adding compatibility of our robot with Pilot robot, which is it's a Python API meant to drive robots with different robots with a common syntax. So if you have you will use the same Python script. So the middle part of the Python script defining the protocol will be the same, and then you will have a small bit on top defining what robot you're using and what deck you're using. And here's my deck. I called it the silver deck, and it imports all of the objects that are found here in the containers, the work platforms, the workspace. And it populates it translates those objects to PLR objects, and then you can use the regular PLR functions if you're familiar with them. I will not show PLR. I assume you're familiar with it, but it's essentially like the OpenTrons API. Only it's meant to be hardware agnostic. Of course, the agnosticity is something you have to work on. It's not something you get for free, so it took some effort. And lots of help from Rick, so thank you. Yeah, he's not here. I hope he would be. I guess he couldn't come. But I'm really happy about this because now, as I'll show you next, our robot didn't have an API. Although it had lots of software and didn't write one. The fourth output is the documentation. which is freely available, published in GitLab pages. The most complete part is the assembly guide and the software setup and the technical overview, and there's lots of work to be done. So this is definitely a thorn. The documentation seems to be an endless task that never ends. So there, I will talk about them as growing documentation. It's never done. If you want to use it and want to make a robot, please tell us. Get in touch, and we will help you. But do expect it to be a very DIY project at the moment. Though we have stopped already modifying the model, so we should be able to work on this and finish it by the end of the year, but for sure, perhaps earlier. But for now, it's still work in progress. So that should be a disclaimer. Let's see. So I'm also very proud. This is not really directly related, but we are very proud about our technical documentation templates. We interacted a lot with undergrad students last year, and having these templates for them to work daily and then migrate their results to the wiki was fundamental to get anything written at all. And really, it works. So this is I think this is worth also having a look at, if not one thing to look at from the project, besides the hardware and everything else. Well, the sources live on GitLab. Everything is here. Here is the UI, the hardware, the documentation, and there's the central controller module and other stuff that goes with that. And now I will talk a little bit about communities on this, and also start saying thanks. So lots of people were involved in this, and I am particularly thankful to some of the members of the Rigosh network who got me started and supported me all the way. This is Renan Soares, and this is Pierre Padilla. Well, the Rigosh network is like the Gosh network, but for Latin America. And they are very much, all of Rigosh members are Gosh members as well. But we focus on our own context and work on projects like this one. I'm very thankful towards Facundo, who is my cousin. He designed and conceptualized the whole user interface. Bruno designed the mechanics of the pipettes, which we will have a look at now. Gaston and Martin have been fundamental support and to get a place for the project to live, and also have it was essential to talk and to build this robot together. And here is Lilo, who visited us, and we were very excited to have her. And Nico, the one that makes the pipettes on the lathe, the UI developers, and I don't know the word in English, but here are the undergrad students that worked with us last year. Here is where we are. This is the University of San Martin, and here's the small workshop where we have some machines that came in handy for developing all of these. We got support from Gosh, and from the Slout Foundation, and from the Provincia de Buenos Aires, the state of Buenos Aires. And well, this is a heavy slide. Let's skip it. So the community of projects, I will come back to it later. So the community of projects, there's a community of people, and I hope that there will be also a community of projects. And here is a small example of what could be integrated into the robot that I only worked on as a proof of concept. So here's the colorimeter module from IO Audio, the Pocket PCR from Gaudi Labs. I'm working on integrating the BioPick plate handler, like Petri dish handler, really, and coloring picking robot, and making a simple centrifuge with a simple fork library. This is I would be really excited to learn what you would like the robot to have on its workspace to do stuff. And yeah, I can perhaps talk about this now as a bonus track. So this is a small but already complex map of what I perceive the open lab automation multiverse to be at the moment. So the easiest way to automate is to get a PhD student, right? So he gets pencil, or he or she gets pencil, paper, brains, and hands, and does all the stuff. And it prepares itself, which is very nice. Then there was the Python Next project, which is has been developed by Deran Dere, with the idea of avoiding all of the OT2 stuff downstream of the API. So it's an OT API mimic, and to use open hardware with this. So I talked with this guy before embarking on all of this, and he told me that I shouldn't use his project, but that avoiding all of this part was a good idea because it was very hard to split into modules and to reuse. So I went my own way, which is over here. The idea, though, was to benefit from the protocol designer output and libraries from OpenTrans. And this is something that Science Jubilee has done, which I think is great. And by reusing those, they gain access to lots of work done calibrating different labware. I call them platforms. And for now, they have one machine that runs the RAP firmware or Duet firmware, and the machine is, of course, the Jubilee. Our path was missing the Python APIs, the Python API, so I made two adapters to get in and out of it. And so as of last week, it works. So we now have a Python API, and the idea is to be able to continue this way, to be able also to use our user interface with the expensive black boxes that Rick's lab has, like the Hamilton and TCAM robots. I will mention just one thing about this part of the image. Our Pipettin's part of the software is meant to be really modular. So it has a plugin system, so you can write handlers for custom actions that come from the protocols, and those can do anything. They're just Python modules, so they are expected to respond to a standard set of commands and give back some information, and that's it. And well, here's the hardware part, which runs Clipper and can run on any most popular MCUs, and also shares tools with Jubilee. So now to the part that perhaps some of you were waiting for, the unboxing of pipettes. So why don't we have OSH micropipettes already? So there are a few efforts on this. Most of them use syringes, which is not really ideal because most syringes are meant to be of single use, except those, for example, from Hamilton or Gilson that have a Teflon seal inside, and well, are meant to be reused and autoclaved. But we don't have proper micropipettes, proper reuse of micropipettes that are open hardware. So the concept is really simple. There's an air cushion, a piston with a seal, and then a tip. And the tip gets contaminated with the sample and then is then discarded. And that's it. We have to replicate this, which doesn't seem very hard, but for some reasons, biologists are really afraid of micropipettes, even though we use them all the time. And here are our faces in terror, disassembling the OT2 micropipette, which was sadly deceased in Lila's lab, and she gave one to us, and also tear it down with us. And here are the parts. So sorry about the gory images. It is very simple. So it has a holder for the tips, This is the P300 pipette. It has a tip ejector. There's a seal inside the chamber, which you can see here is just an O-ring. It is a lubricated O-ring, and that's an important detail. There's a steel rod that passes through this O-ring and now increases and decreases the dead volume inside the holder to aspirate and dispense, of course. And there's a lead screw, a nut, and a stepper. Everything that you would expect if you did it yourself. So we did it ourselves. This has been going on for a couple of years, and it was really nice to see the OT2 tear down, because I got the feeling that we were doing things really well. And this is our new pipette. So it's very simple. Here's the tip holder. As I said, it can hold multiple tips. And the way that it ejects them is to move to a certain position, and there's a fixed ejector in one place. Because we have not yet implemented the multi-tip ejector that goes over it. We turn this is the only part that you have to turn on a lathe, and it has the really neat property that if you turn it really well, then you can put your finger on the other side and the piston won't fall off. And it's a seal all of itself without the O-ring. And then you can place the O-ring and squish it to get a really, really good seal. I think this property is really nice because in the case of rapid pipetting, the O-ring may, in other situations, may not be able to hold the pressure. So having this part, this behavior will come in real handy when trying to pipette really fast, like for mixing. So I will wrap up. There are some takeaways for you. I hope you learned that Pipettin bot is fully open source. It's cheap and designed for lab automation. We will have complete assembly docs for the latest version this year. It can be used entirely from the browser and also by coding, and it's compatible with other projects like Jubilee, Pilot Robot, and many control boards. So you can choose your own. If you want to do something now, you can join the Discord, which is over here, and get involved in any way that you like, and do some happy pipetting. Well, that's it. You can reach us by email too. Thank you for your time.
All right. Give Nico a round of applause. All right. I'm seeing the little clapping emojis. I love it. Thank you, Nico. Does anyone have any questions for Nico? I see Lilo's hand up.
Yeah, I have a question, Nico. This is great. Thank you for the. I mean, I knew some things, but I learned some things also about Pipettin, and I love and I'd like to see how it can actually grow together with Jubilee and other efforts. One thing actually that I'll share that was presented to me and I was not aware of in our latest trip. We went to Slovenia with Jubilee, and there was a group of people that were very aware of open source licenses. And they were actually making a point that we should make sure that whatever license we choose is share as, which I had no awareness about this. You probably guys all know about this. Have you heard about this, Nico? Share as?
Sorry? Sure.
The idea is
sure,
that there are some licenses that if you give it completely open, even for commercial uses, somebody could actually take your design and leave their changes closed. So they are not required to essentially do open source sharing of any designs that they actually do based on your own original design.
Right.
So there are alternative licenses that actually requires that anybody that does any modification based on your design, even especially for commercial uses.
Yeah.
What is that?
Those I'm not an expert, right? Perhaps someone can chime in, but those would be, I think, the copyleft licenses. I am using the CERN OHL-S license, which is the most restrictive in the sense that you can, restrictive in the sense that it cannot be closed. So every modification that you make must be shared under the same terms.
Super.
And the software is, since it will run on a web server, probably use the Afero GPL license, which also requires that any software that runs on a server and is served is also, any modifications to it must also be shared. These are, to me, the standard choices, but there may be others. I realize there have been many new licenses emerging for other kinds of business models, and I don't know much about them, so I don't have a strong opinion. So I'm sticking to those for now.
Yeah, I think that is great. You probably know about this already more. It was new to me, so I figured I would share it. And I guess the question I did have is about like, how do you see this interfacing with like Texi, in the sense of like, you guys put all this work, right? And I think that most scientists, and we're approaching this from the side of scientists, would like to be able to purchase components that come for Pipettin, for example, as a kit, the way we do as when we purchase kits for Jubilee, that facilitate and minimize the headaches of putting it together, even though it still sometimes has some headaches. So can you comment on how do you see like the future of like, is it like just going to be a list of parts and everyone to their own based on the instructions, or do you see it like there's a potential business model?
Well, I think there is an intermediate. We will try to get as close as we can to commercializing it, just to serve everyone, the needs of everyone. That might be different, right? So we have the UI and we have the Python thing, and we would like to also, be able to send you a full robot and also just give you the parts list and the kit as well. We would like to do everything, right? So, but time is the one thing we are missing right now. So we will probably document the robot. So make a few kits, build one, document it, and then put it, make the kits available. Because the parts its parts are so common. They are, I believe, they can be found anywhere. It would be easy to try to establish a distributed manufacturing model. Like, there are some initiatives inside GOSH to figure out what this means exactly. But the idea would have to be, we would have partners in different parts of the world to implement that. So there would be one kit, but the work and the manufacturing would be distributed. I also see that perhaps Jubilee and Pipettin have slightly different target audiences and also different functionalities, because Jubilee is much more precise in its motion and on the bed leveling, which we did not do because it would have been the same project, firstly. But secondly, because we did not see it as a need. So perhaps there can be a Jubilee there could be a Pipettin here, and well, we could try to figure out what is the best way to get this used by people, and to get it to benefit them, to make the technology really accessible. So I want people to use this. This is really the thing. I started this trying to say, well, I am stuck in my house. I want a robot, so when I go back, the robot will do the work I couldn't do. And I ended up really loving the project, and realizing how much the technology could benefit science in general. So I really would like people to just use it, and any ideas on how to get that done are welcome, and all hands are welcome.
Nico, I'm interested in your universal pipette tip. So that's something that you've designed, and is it working well? And how do you eject the tips?
Yeah, well, I am in my house, right? But here's the pipette, and so you have those. Let me see if I can show you this thing more or less.
You might have to drop out of screen sharing.
Ah, yeah.
Yeah.
Is that
Yeah.
done? Okay. So we have the tip holder right here, and you have the different steps for the different tips.
Yeah.
And so how the tip ejector works is that you have a fork with four
Yep.
fingers,
I
one
see.
of
Yep.
each size.
Yep.
And you just eject them. You move the pipette over there and eject them. But that's like the first order solution to this problem. The real solution, which I would like to have, is to have the usual tip ejector mounted on the pipette, and that would be a pair of clamps like this that moves over a smoothed surface on this side, which it's not right here because this is the first prototype, but you've seen them in the blueprints, and that just does the same motion any tip ejector would do.
Cool. Cool. Yeah, I love that design.
It works well. The tests have been, just hanging 4 of these with different tips and liquid in them to see if they leaked at all under gravity, of course. And a few, basic tests by actuating it manually. I finished this pipette like 2 days ago. So, but it's really been wonderful and hasn't failed even a single bit. And I'm really happy and excited about it. It's been 2 years since we started this one. I think everyone will be happy to because it's so simple, right? Everyone will be happy to reproduce it. So you can sort of take it apart, and the middle part, well, it didn't come out, but there's a small dowel pin there that's very smooth and corrosion resistant. So it's made out of really available parts, except, of course, for the tip holder, which you can try to 3D print in resin, but it's a little brittle. We have tried many things because the lathe broke in midway. This is why it took so long. But now it's working and it's wonderful.
Yeah. Okay, cool. I've got access to a manual lathe, so maybe I'll try it sometime to turn one of them.
Yeah, get some tips and try out a few angles.
Mm-hmm.
So we did like 5 of these with 5 different contact angles, and each tip is also its own universe.
Yeah.
So you have to try and test. We did our best to fit all of the 4 or 5 tips we had laying around, but it comes down to testing. This is why I think most robots give you their own tips, because it's troublesome to just use any tip.
Brendan, I saw earlier you put a McMaster X profile ring into the chat. Do you want to speak to that for a second?
Sure. Yeah, I was thinking about, Nico, I think we're talking about like pipetting fast and maybe having O-ring issues. You were alluding to that. Maybe this is another option. I guess I can screen share so everyone can see the links in the chat. These are just like another O-ring style that has 2 contact points. And I know this is used for things where you have like really fast motion. Just a thought, if you're having issues, it's probably overkill for what we're doing here. But.
No, yeah, I looked, and this one I didn't know about. I would have a look at it. For now, we don't have any issues, fortunately. There are some also design variants. The O-ring one is the simplest one. There's another with a Teflon hat. I call it that way. That should be really, really good. But I have not seen this one. We'll look at it, and perhaps when we test it out, stress test it, it will show the problems, and we will have to use some of this. Thank you.
Yeah.
Any other questions for Nico?
I had one more question. So you have tool changing capability, but right now you're only pipetting. Have you thought about like what's next, or what would you like for your workflow to do next?
Well, I found this plate Petri dish handler, which does these motions, and it can grab the small plates. And I work with yeasts, right? So it would be really nice to have this little machine to grab the plates and move them around and pick colonies and start cultures. that would be like a little microbiology station on its own. I think this would be, for at least for what I'm doing right now, the next step. And this project also comes with an OpenCV program to detect the colonies and things, but I would probably rewrite that just to learn. I mean, there are lots of things. The simplest implementation of the self-driving idea that I want to test would be the colorimeter, to just get a growth curve and try to check that a feedback system is possible with the current software architecture, and I won't find any surprises, I think. And really, that's it for now. In the long term, what I really want to do is automated microscopy experiments, and like trying to draw causal relationships between phenotypes and stimuli in an automated way. And this is a very, very long-term and complex project. I'm just scratching the surface of that, but I would like to have an automated microscopy set up for that. I don't know if microfluidics may be a part of it because it's rather complex, but I can do it without tier 384 well plate for microscopes. So perhaps I don't need that. Perhaps I do. I don't know.
Hey, Nico, that plate picker that the hand that you just showed, is that off the shelf or is that 3D printed or?
Oh no, this is a 3D printed. I 3D printed it and I downloaded it from the GitHub repository of BioPic. So if you look for BioPic GitHub, let me just search it for you real quick. The models are there. Well, I'm actuating it by hand because the servo I have is too large. It doesn't fit. So I'm only moving it with my hands. But yeah, it works really well. So it has a little gear there, one for moving it, separating the arms, and the other gear here is for moving
this is a great design. I've been building something similar, so I love it. So thank you.
That's awesome. We should get these people into Optima Club.
Who was talking just now?
James.
James. I'm sorry, I don't know how to use Zoom. I don't see you. But
hold on a second. S. James. Hold on. Let me turn my camera on. I'll wave.
Okay. If you want to, hi. If you want to talk about this, I'd be really interested to exchange ideas and see what's best, because this is the thing I found for now, and I thought it was really cool.
Yeah, definitely. I have your email address, so we'll definitely be in touch.
Okay, great, awesome,
great,
awesome.